Sony Pictures ImageWorks, and it's an open source shading language implementation that you can plug into basically any renderer, and we decided to plug it into 3ds Max 2019. It shows up as basically three things. First of all, it's a brand new map called the OSL map, but there's also a whole new category of maps simply called OSL. And finally, there's some interesting little development tool thingies I'll be showing a little later. So yeah, let's go. Anyone who's been using Max for any length of time is quite familiar with the good old general category of maps. There's a bunch of them in there. They've been with us for years, and every year there's like one or two added because it's quite a significant effort to write a new map for Max. And we got some stuff like the shape map or blended box map recently. This year we get two new in this category. We get the advanced wood, which is cool in itself. We'll get to that one later. And we also have the OSL map, which allows us to use OSL in Max. However, I won't get to this one just quite yet. Instead, I will close up our general category and notice there's a brand new category here called OSL. This contains a bunch of shaders that we can use. I have this sample scene here of a teapot on a piece of box sitting somewhere in Paris. Environment map of Paris. I will start my active shade with that and just randomly drop in an OSL shader, like for instance this checkerboard map, and we will see that yes, this works, renders, and is fully interactive with the Arnold active shade. So we can see it. We can drop in another one like this Mandelbrot shader, for instance, which is if you're into fractals, this might be interesting. We have one that does, for the steampunkers among you, I wrote us rivets shader, which adds a set of rivets around the squares in UV space, and there's a whole bunch of features on that. I won't go into the details. Now, what I'm demonstrating here is Arnold. But don't let this deceive you that this for some reason only works in Arnold. That's not the case. I can show you this rendering in good old Scanline renderer. We will find that our rivet scene looks pretty similar in Scanline to what it does in the Arnold active shade. But of course the difference is that the Arnold one is interactive. Doing this means, of course, that the shaders work everywhere else in Max where shaders can be used, like the displacement modifier or wherever. You can do, render them, bake them to texture, or do whatever you want with them. Here's a quick example of the rivets in a more real-world action. We have a setup here which takes a UV channel, puts it through a transform and into a UVW row offset, which is what gives these offsets for each of the rows. So if I say, for instance, 3 here and 0.33 offset, we'll have every 3, like a 3-row offset. All this goes into the rivets shader itself, which of course does all sorts of stuff with the rivets, like you can define the probability of how many has fallen out. So now we only have 40% of the rivets visible. There's wobbliness for each of the metal plates, so we can make it look all kind of bent out of shape. And of course there's the colors and all the obvious stuff. The values from that then gets fed through all these outputs that the shader has. For instance, the plate index that goes into index-based randomizers like this one, which takes an input index and a random seed, which we can flip around, and sets like a brightness value on each of the plates by multiplying that with the color and toss it into the material here. So this is the kind of way a setup would look. And the interesting part of this is, of course, the UV side of things, where we're feeding in UV coordinates. If you don't feed UV coordinates to a shader, there will be a default setup, which is here just like a single UV mapping across the object. And of course, this is coming from a UV channel. I have an option here where it comes from the object space. So now it's projected kind of from above in object space. Doesn't make much sense for this scene, but it just shows you that UVs can always be driven, unlike how it works in the classical max shaders, where UVs are just a built-in thing and you can only do what that does. Here you can do any math to UVs, randomizations, or all sorts of stuff to make really complex and cool things happen. Another one that is useful out of the books is this one, the randomized bitmap. Let me turn on the renderer and see what that does. Basically, it can pick a bunch of image files, up to 10, although you can cascade them together to get more, and mix them with shifts in hue, saturation, value, whatever. So let's demonstrate it a little by turning down the number of bitmaps and turning down some of the changes. So let's reset our hue shifts and our saturation shifts, like that. So now we don't have that. We can turn back to, say, use 5 of the bitmaps. We can change the random seed, which can be done per object if one wants. We can turn down the probability. There's fewer of them. We can play with the scale, so we get smaller ones. I guess we need more probability for that, etc., etc. The probability can be driven by a randomness function to clump it, and we can do rotations and basically everything. It can make, transparency, and on and on and on and on and on. Lots of fun with that one. So that's these shaders or maps. I keep saying shaders because in OSL they're technically shaders. Max calls them maps or materials, depending on what they are. But we have these, Baker's dozen, and something I should show you maybe here is all the different categories that also exist for mathematical floating point operations, color operations, vector operations, getting data from the scene, like, frame numbers, material IDs, objects ID, particle edge, switchers, logical compares, the all-important UVW category, which synthesizes, transforms, and tweaks your UVs in all sorts of ways that you could never possibly do normally in the old school max shaders, and drive anything anyhow. The sum of this in total, it's actually over 100 new maps. So rather than throwing in like 1 or 2 as we used to do, we throw in 100. So I hope you guys enjoy that. And of course, since these work in the classical rendering API, they work everywhere. They work in your displacement modifier, they work in your V-Ray or Corona or whatever runs the classical shading API, or in the renderers, of course, that support the OSL map directly the way Arnold is doing it. So admittedly, I'm a little bit of a nerd, but to me these 100+ new maps is not really the exciting bit. This, what I'm showing now, is the exciting bit to me. I'm loading in the OSL map itself, which is basically the blank slate for OSL. It doesn't do anything until you load some shader into it. And I have here some stuff I just downloaded off the internet. You can literally Google OSL shaders and find hundreds, if not thousands, all over the place. This is a thing that does some kind of wiggly lines, it seems. Maybe great for cat hair on a couch or something like that. Or I can load in another one here. It's one called Stones, which seems to be, it's very small, but seems to be some kind of randomized tiles of some sort. Could probably be useful. There's another one here I can load in. See, it's over here. It's called Leopard, which makes like the dots on a leopard, like so. Also pretty small. Zoom in a bit. And it has a secondary output called D, which is I guess some kind of distance from the center of the leopard dot. I don't know, could probably be useful for something. So loading in shaders you found anywhere on the internet, most of them should work as long as they work as textures, as maps. We do not yet support materials in this release. Stuff that returns closures will be in a future release. But now comes maybe the even more interesting part. Let's make a simple example. I loaded in this checker.osl, which by the way is technically not checkers because it works with the stacked cubes. That's why it looks weird alternating. We find that it behaves in a strange way. We try to turn up the scale and notice our cubes get smaller. We find that weird and I wonder what this shader is doing. Well, we just click this button and up pops the source code. So here we see, for instance, the input, position, scale, color 1, color 2, and the output color. We see some math happening here with the scale, something, time scale, whatever. We realize it's working backwards, so maybe what this code means to do is divide by scale. Let's try it. We compile it, and while it were rendering, it's actually recompiling our shader. And yes, now we have something that behaves the way we want. It scales up as we turn up the parameter value. We can even extend this shader with some, I don't know, some additional feature, saying we add a parameter called bright, and at the end we just multiply the color with bright. Now check what happens when I hit compile. Look up here. Bang, we have a new parameter, a new input called bright, which you can turn, and we can, we have just extended it. But wait a minute, you say, Zap, what happens? Have we actually now modified checker.osl? Will this break other scenes that use checker.osl? No, it will not, because you'll see here it says modified stored in scene. This code, our modified version, actually lives literally in this actual map as basically a string with this code in it, which means it lives completely in the scene. So if I send this scene to a render farm in Hawaii or whatever, it will render with this without me having to send anything with it. It's all completely embedded. Of course, for the particular case of changing the brightness, I wouldn't really have had to go into the code. I could kind of just as well take the color multiply and drop it on the wire and do a multiplication here. Of course, that does exactly the same thing effectively. Both ways are equally valid, and since OSL actually optimizes entire shade trees in its compilation step, it's actually not technically any different. One isn't more efficient than the other. So there you have it, some ways you can literally edit shaders while the renderer is running. And for the actual developers, you can even use the OSL map itself as the blank slate, because there is some sample code inside it, which at least gives you a hint of the syntax of the shader, so you don't do complete nonsense. Of course, it's syntax highlights and it has error reportings and things like that. So it's pretty useful stuff. So if we go back to the beginning, you remember I said we would have an OSL map, which we have. We would have a whole category of shaders, and we would have a development tool. We would have an OSL map, shaders, development tool. Are you getting it? Okay, these things are all one and the same actually. There's actually no difference between this OSL map and things loaded from these categories, except one thing. The things loaded from the categories down here come in the linked mode. That means they are working with files. So it will actually load these files, and would load it at runtime. When you render, it's using this file. So there's a connection to the file, and you can't edit. You can look at it. This is a viewer button now, but you can't edit it. However, since these are all one and the same, you can unlink it, and now suddenly this is stored in the scene and you are allowed to edit it. So I could do something to this shader. I will just do something random, doesn't matter. Additional parameter, bang. Or if you change your mind and say, no, wait a minute, I don't want that, you can just link it again. It will inform you that, hey, you had edited it. I say, no, that's fine. Bang, it undoes back to the original, the source undoes back, this goes back to read-only viewer, you're linked again, you're connected to the file, and it will always now follow the file again. And for the developers among us, there's also a lot of options to customize the shader in such a way that it can contain metadata for things like tooltips, and you can control help texts, links, and even modify the little logo down here. And the developers can also deploy their shaders to the plugins directory and have them automatically show up here in the category. So these are some of the things you can do with the OSL in 3ds Max 2019. I hope you will enjoy it, and this is Zap out for now. Bye bye.